Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will learn about the control principles of AC servo motors. Our lesson will cover the following two main topics. Through this lesson, you should be able to accurately describe the operating principles of each control method and choose the appropriate control method for specific application scenarios. Understand the structure of a three-loop control system, grasp the logical relationships and interdependencies between each loop, and analyze the system's dynamic response under three-loop control. In recent years, servo motor control technology is advancing towards three main directions: AC-based, digitalized, and intelligent systems. As the actuating mechanism in CNC machines, servo systems integrate power electronics, control, drive, and protection into a single unit. The technology has evolved from stepper motors to DC, and now to AC, driven by advancements in digital pulse width modulation, special motor materials, microelectronics, and modern control technologies. Let's start by understanding the three control methods in a servo system: torque control, current loop; speed control, current loop, speed loop; and position control, current loop, speed loop, position loop. Torque control. The main goal of this method is to control the torque of the motor. It sets the torque output at the motor shaft through an external analog input or by directly assigning values to the address. For example, if the external analog input is set to 5 volts, the motor shaft outputs 2.5 Newton meters. If the motor load is less than the set torque, the motor rotates forward. If the load equals the set torque, the motor stops. If the load exceeds the set torque, the motor rotates in reverse. Torque control is commonly used in applications requiring precise torque control, such as winding devices or fiber pulling equipment. Speed mode. The main goal of speed control is to regulate the motor's rotational speed. It can be controlled by an analog input or pulse frequency. In systems with an external PID control loop, speed mode can also be used for positioning. Additionally, in position mode, direct load detection of the position signal is supported, where the encoder on the motor shaft only detects motor speed. In the position signal is provided by a detection device at the final load end. This approach reduces errors in intermediate transmission, improving positioning accuracy. Position control. The primary goal of position control is to regulate the motor's position. It determines the rotation speed through the input pulse frequency and the rotation angle through the number of pulses. Position control is used in applications requiring high-precision positioning, such as semiconductor manufacturing, PCB production, and machine tool processing. Let's continue by looking at the control principles. Current loop. This loop operates entirely within the servo drive. It uses a Hall sensor to detect the output current of each phase that the drive supplies to the motor and applies negative feedback to adjust it against the set current via PID control. This enables the output current to match the set current as closely as possible. The current loop controls the motor torque. So in torque mode, the drive performs minimal calculations, resulting in the fastest dynamic response. Speed loop. The second loop is the speed loop, which uses signals from the servo motor encoder to apply negative feedback via PID adjustment. The output of the PID in this loop directly sets the current loop, meaning that speed control involves both the speed and current loops. In other words, any mode must utilize the current loop since it is fundamental to control. In systems that control both speed and position, current, torque, control is also applied to achieve the desired speed and position control. Position loop. The position loop is the outermost loop and can be constructed between the drive and the servo motor encoder, or between an external controller, in either the motor encoder or final load, depending on the specific application. The output of the position loop sets the speed loop, so in position control mode, the system runs all 3 loops, making the computation load highest and the dynamic response slowest. In this lesson, we covered the control principles of servo motors, including the 3 control methods: torque control, speed control, position control, in their application scenarios, as well as the operational principles and interactions within the 3-loop control system: an internal current loop, speed loop, and position loop. Typically, a servo motor control system uses 3 loops: the current loop for torque control, while speed and position loops incorporate speed and position control, concurrently regulating current, torque, for the desired speed and position adjustments. Through this lesson, I hope students gain a deep understanding of the control principles of servo motors, laying a solid foundation for future study and work. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.